Alright, so section 8-2, the reciprocal function family. Our learning objective is to graph reciprocal functions and graph translations of reciprocal functions. So let me first show you what a reciprocal function is. It's y equals a constant a over x, and the parent of this is y equals 1 over x. And in both scenarios, x cannot equal 0, 0, 0. Alright, so the translation looks like this. Y equals a constant a over x minus h plus, okay. And let me give you a breakdown of terms. Just like in all of our other functions, A determines stretch or compress. If our A is greater than 0, it's a stretch. If our A is between 0 and 1, it's greater than 1. Let's think about it. Hold on. If our A is greater than 1, it's a stretch. If our A is between 0 and 1, it's a compress. If our A is negative, then it's a reflection across the x-axis. And H comma K is the translation. So let me show you how that all works together. All right, so let's look at what the graph looks like. We did a little bit of this in the last section. I have called it the diagonal U shape. So if we were to graph the parent function y equals 1 over x, when I plug in, I obviously can't plug in 0 for x. So when I plug in 1 for this x value, and I'll just show you when. So when I plug in 1 for my x value, it's 1 divided by 1, and that's 1. So then I plot that point right here. When I plug in 2 for my x value, it's 1 over 2, so that's 1/2. When I plug in 3, it's 1/3. When I plug in 4, it's 1/4. So it rolls all the way down and gets very close to my x-axis. What happens here? Oh, when I plug in 1/2, 1 over 1/2 is 2. When I plug in 1/3, 1 over 1/3 is 3. So as I get closer and closer, we get closer to our x-axis. And then you go, what happens when I plug in -1? If I put negative 1 in for x, I get out 1 divided by negative 1, which is negative 1. So that's right here. If I negative 2, I get negative 1/2. So negative 2, I get negative 1/2, and the pattern continues where? So that's my parent function. I call it diagonal use. If I were to graph y equals 1 over x minus 4 plus 1, it means I take my whole graph and I shift it to the right 4 and up 1. Now, it's a little bit difficult to do, so I'm going to identify some key points on my graph. So I've got 1, 1, and negative 1, negative 1 on. So I'm going to move to the right 4 units. So if I took this point 1, 1, and I just went over 1, 2, 3, 4. So now I've got my graph looking like that, and I went to this point here, 1, 1, and I moved it over 1, 2, 3, 4. Then my graph of my parent function is in red. Another way to look at it is that I have an asymptote right here. I can't equal 0 on my x-axis, and I can't equal 0 on my y-axis. So I can move that asymptote over 4 units to the right and 1 unit up. So then that becomes my new, and that might be actually a better way to graph it. You get actually a more accurate graph. Definitely. So as you can see, my little red line, he went row here. Let's get him back on track. So he is following that asymptote. All right, so I have 2 example problems. The first one, what is the graph of y equals 12 over x? We get to name the x and y intercepts. And asymptotes. And we get to identify the domain and range. So let's put our graph down. So given what we have here, our reciprocal function, our parent function looks like y equals 1 over x, and the function that we have just has, it's either going to have a stretch or a compress. So let's look at our equation. Does it have a stretch or compress? Which one? It doesn't have any movement. So if A is greater than 1, it's a stretch. If A is between 0 and 1, it's a compress. So let's look at our A value here. So in this case, a is greater than 1, so we have a stretch. So we're going to have our same basic parent function, it's just going to be stretched out. So let's make a little xy table and get a shape. Let's go -2, -1, 0, just for fun. -1, or sorry, +1, 2, and just for fun, 12. Alright, so when x is equal to -2, y is equal to -6, because 12 divided by -2 is -6. When x is equal to -1, y is equal to -12. When x is equal to 0, we are undefined. When x is equal to 1, y is 12. When x is equal to 2, y is 6. And when x is equal to 12, y is 1. So let's plot those points on our graph. -2, -6, -1, -12, right down there. 0, it's undefined. 1, it's 12, way up here. 2, it's 6. 12, it's a 1. So that's going to look like so it looks a little something like this. What are the x and the y intercepts? Where does it cross the x and the y axis? No, it doesn't. Yay! I love it when that plan works out. So the x and y intercepts are we can just put none. Yay! What about a little bit harder, domain? What x values am I not allowed in this problem? What is my domain? What can't go in for x? Yeah. So my domain is all real numbers except x equals 0. So I get all the real numbers except 0. Not allowed. And then my range. Is there any y values that I can't have because of either my domain or just the way the function looks? Is there any restrictions on my range, my y values? Can't equal 0, which means my asymptotes are x equals 0 and y equals 0.